Hello again, this is Tim Bivens for CSC 118 Swift Programming 1. And today we're going to look at lesson 1.6, Building, Running, Debugging an App. In an earlier lesson, we talked about Xcode Simulator, which allows us to test our apps in a variety of devices and screen sizes. In this lesson, we're going to walk through the necessary apps to configure your Mac for building and debugging apps, and use the simulator to test your apps from Xcode. We'll also learn how to run your app on a physical device, although we're not going to focus on that too much here because some of you I know do not have a physical iOS device. So we'll learn how to use simulator to run apps within Xcode environment. How to run an app on a physical device, as I said, maybe, and how to perform basic debugging using breakpoints. That is important. Make sure you look over the vocabulary, click on them, understand what the definitions for each of these words are. All right, let's get started. Building and running. All right. The first step is to create a new project in Xcode. Again, we'll use the same iOS single view application template as we did in the previous lesson. So click on Xcode. You got our standard Welcome to Xcode screen. And click on the second option, Create a new Xcode project. As I said, we're going to do a single view app. And we'll name this Getting Started. We want to make sure we click on Storyboard as opposed to Swift UI. Note that it defaults to Swift UI, which is a new system for creating UI in Swift, which appears to be a very good system and an upgrade from the old one, but the book is not yet supporting or teaching that, so we're going to go with the old way. So make sure you click on Storyboard at the beginning. Once that's done, I'm presented with the Xcode workspace. Locate the scheme menu on the Xcode toolbar, which is right here, and choose a scheme that you want to use. It doesn't really matter. It goes all the way up to iPhone 11 Pro. So I do that just to see how big that screen is. Click the Run button or use the keyboard shortcut Command R to begin launching the app in Simulator. Sometimes you have to switch to Simulator. It won't pop up in front of you. So you can use Command Tab to switch applications, and that's what I do here. So I'm Command Tab over to Simulator, and you can watch it launch. Sometimes it takes a little bit. There you go. And the blank app is just a blank white screen, so it is running as expected. If you are running an app for the first time, Xcode will ask whether you'd like to enable developer mode on your Mac. And you most certainly do, so definitely click Enable when asked to do so. The simulator may appear quite large depending on the screen resolution of your Mac and the device you choose to simulate. You can change this by following these directions here. To quit Simulator, use the keyboard shortcut Command Q or just go back to Xcode. It's important to note that Simulator doesn't work for all portions of an app. There are certain things you can do on a phone that Simulator cannot simulate. So if you ever get serious about iOS development, you will need to get an iOS device to actually test on. For our purposes, Simulator is going to do everything we can, or everything we need, because that's all we can do, right? Using your personal device. If you're interested in doing this, by all means, if you have a physical device, read about it, and if you have questions, you can ask me directly through email. But I'm not going to go over this online like this because it would be too hard to handle any errors you might run into. Also, you can build and run wirelessly. Again, this is not something I'm going to cover here in this class, but by all means, delve into it if you're interested. But debugging the application, we're definitely going to work on, so let's look at that. No developer writes perfect code, ever. We all struggle with this. Debugging is the process of identifying and removing problems that may arise in your app. As you proceed through this course, you'll encounter 3 types of issues: warnings, compile errors, and bugs. Warnings are simplest things to fix. Some things that can cause warnings are writing code that never gets executed, creating a variable that never changes, using code that's out of date, or also known as deprecated code. That's important to know, and definitely know the definition of deprecated code. So now we're going to take a look at the Viewcontroller Swift, and we're going to play around with this a little bit to create some errors that we can fix. So we're going to come in here and add the following line of code just below super.viewDidLoad. As soon as we do that, we get a warning. It says initialization of immutable value x was never used. Consider replacing with assignment to or removing it. The compiler is telling you that it created X, but since it's not used in a meaningful way, you can remove it. Delete the line and rebuild to remove the warning. Next type of error is compile errors. These are important. These prevent the compiler from compiling. So there's some error in the code that makes it uncompilable, right? So we're going to go to Viewcontroller Swift and remove the open and closing parentheses on the end of super.viewDidLoad. Right there, right? And immediately we get some errors. Make sure you put the navigation controller.title in there. That's the second error, right? I forgot to put that in there, so it doesn't actually show up. Errors with a dot in the center, Xcode would display a suggested fix to it. So you can click on that and say fix, and it will actually attempt to fix it for you. All right, so now I'm just making mistakes all over the place. All right. All right, we finally got to the place where it looks like in the book. All right, so the bottom one with the dot in the center, click on it, and we'll take the first fix. So you can just click on fix, and it will fix the problem for you. The ones with exclamation points, the Xcode will not fix for you. You have to fix it for yourself. So put the parentheses back in, and that error will go away. The third type of issue is known as a bug, or also known as a runtime error. These are harder to figure out because the syntax is fine. It's just it's an error in your thinking that led to the issue, so it's harder to track down. But to check this out, let's type in these 3 lines here, right? Or 4 lines, I guess I should say. Var names equals square bracket Tammy colon Cole. Let's say names, remove first, and we're going to do that 3 times. All right, and once you've done that, you build it, we'll say build succeeded. All right, so the build succeeded. Now try running the app. And we get an error. Why did we get that error? Fatal error, can't remove first item. Program crashed when it tried to remove the remaining first element and couldn't find one. Because we removed more elements than we actually had. Before you start looking for the bug, you'll need to add a breakpoint to your code. Create a breakpoint by left-clicking in the gutter area to the left of the line where you want the execution to pause. Gutter area is over there where those numbers are. All right, build and run your app. You'll see the program pause at the breakpoint. That's good, right? Look down here. All right. Click the Step Over button to advance execution by 1 line. In the variables view, you can see that the names has been assigned the proper values. So far, so good. All right. You can see, yep, we step over again, it removes 1. Step over again, removes 2. Try the step over one more time. Error. Right, so we've tried to remove 1 more than we needed to, right? So what we need to do is remove that last call to remove first so that it doesn't overstep its boundary, so to speak. And then we'll run it again and check it out. And it looks good. Debugging is a crucial skill for developers to build. When debugging, take the following approach. Try to understand the problem, brainstorm a potential solution, try the solution, verify it worked, repeat as necessary. The lab will be in a separate video, so we'll go to that one now.